Energy. Why does it happen? When a pot, if a pot having a plant is kept in the dark, the plant languishes. When a pot having a plant is kept in the dark, the plant does not get light energy from the sun. As a result, plant fails to prepare its food by photosynthesis and it languishes, meaning eventually it becomes dull, it does not grow properly, and it doesn't remain healthy. Second question, on increasing the volume of a music system or TV beyond a limit, the vessels in the house start vibrating. You all must have observed this. When we increase the volume of a music system or TV beyond a limit, the sound travels through the medium in the form of vibrational energy. This energy then is transferred to the vessels and they start vibrating. Next, collecting sunlight on a paper with the help of convex lens burns the paper. We have done this experiment earlier in 7th standard. When we use convex lens to collect sunlight on a paper, the lens concentrates the entire light energy at a single point on the paper. And this light energy then gets converted into heat energy, resulting in burning of paper. Now let us go through the next term, kinetic energy. What will happen in the following cases? A fast ball strikes the stumps. When a fast moving cricket ball strikes the stationary stumps, the energy in the ball is transferred to the stationary stump. As a result, the stumps, they gain kinetic energy and they get displaced. Next, the striker hits a coin on the carom board. When striker hits a coin on the carom board, the energy in the striker is transferred to the stationary coin. As a result, the coin gains the kinetic energy and starts moving. Next, one marble strikes another in a game of marbles. When one marble strikes another in a game of marbles, the energy of the moving marble is transferred to the stationary marble and it starts moving in the direction of the applied force. So kinetic energy is work done on the object. From the above examples, we understand that when a moving object strikes a stationary object, the stationary object moves. Thus, the moving object has some energy, part or all of which it shares with the stationary object, thereby setting it in motion. And the energy which an object has because of its motion is called its kinetic energy. The work done by a force to displace a stationary object through a distance s is the kinetic energy gained by the object. So kinetic energy is the work done on the object, and we know that the formula for work done is F multiplied by S, that is force into displacement. And so kinetic energy is equal to F multiplied by S. So now let us derive the expression for kinetic energy. Suppose a stationary object of mass m moves because of an applied force. Let u be its initial velocity. So here u is 0 because kinetic energy is only gained in motion. And let the applied force be F. This generates an acceleration a in the object, and after time t, the velocity of the object becomes equal to v, that is final velocity. The displacement during this time is s. The work done on the object, we know that it can be given as W is equal to F multiplied by S, that is force multiplied by displacement. Now to derive an expression, we don't have values, but we have to use our knowledge and the earlier expressions. Now how do we solve this for kinetic energy? We know that According to Newton's second law of motion, force is equal to ma, and displacement, according to the second equation of motion, is S is equal to ut plus half at square. I hope you all remember Newton's second equation of motion is S is equal to ut plus half at square. Now why have we used F and S over here? Because we have the formula W is equal to F multiplied by S. And now why are we doing it? Because we have to derive an expression for kinetic energy. Here we are saying that kinetic energy is work done on the object. We know that the formula for work done is F multiplied by S. Now substitute the values of F and S, that is force and displacement. So force we know is mass into acceleration, and so far as displacement is concerned, we need to go to the second equation of motion. So we come to know that displacement is ut plus half at square. Now let us further simplify this. We know that initial velocity u is 0, and so anything multiplied by 0 is 0. So S is equal to 0 plus half at square. So the displacement will become half at square. Now let us put in the values of force and displacement in our formula for work done. W is equal to F, that is ma, multiplied by displacement S, that is half at square, as we have derived in equations 1 and 2. Now here mass and half is there, but acceleration is multiplied. So it will become half m a square t square. When both of them are square, we can do what is that we can take both the terms in bracket and write it as whole square. So the work done W becomes half m at whole square. Now, although we have derived an expression for work done, but we need to still derive expression related to kinetic energy, and we have to further solve it. We cannot just keep it as at square, because kinetic energy is something related with velocity. So now let us go to the Newton's first equation of motion, where we know that V is equal to u plus at. And here in this case, initial velocity u is 0, so it becomes V is equal to at. Now, how can we use this in our earlier expression of work? Yes, of course we can use this. How? If we square both the sides of the equation, V is equal to at. So it will become V square is equal to at whole square. Now you know that we can substitute at square with V square. And exactly we are going to do the same. So W is equal to half mv square. Okay, we have put the value of V square is equal to at square in our earlier expression of work, that is half m is equal to W is equal to half m at whole square. We have substituted it with V square. And now we get our formula for kinetic energy, which is nothing but the energy gained by an object is the amount of work done on the object. So kinetic energy is equal to work done, and kinetic energy is equal to half mv square. So this is the expression for kinetic energy, which is half mv square. The example here is a stone having a mass of 250 grams is falling from a height. How much kinetic energy does it have at the moment when its velocity is 2 meters per second? So what is given? Mass is given and velocity is given. But mass is in grams. So we'll have to convert it in kilograms. So 250 grams is 250 divided by 1000. So it becomes 0.25 kilograms. Why 1000 it is divided by? Because 1000 grams make 1 kilogram. Velocity v is already given 2 meter per second. Now let us put in these values. We know that kinetic energy is half mv square. So half multiplied by 0.25 multiplied by 2 square. So and the answer comes to 0.5 joules. Use your brain power. The mass of a moving body is doubled. How many times will the kinetic energy increase? The mass of a moving body is doubled. So how many times will the kinetic energy increase? Think about this. And try to find out the answer on your own. We'll discuss it in the next class. Thank you.